I've said it before, but polynomials come in all different shapes and sizes. It is an incredibly broad field of functions. However, the graphs of all polynomials have a few common characteristics. First, all polynomial graphs are continuous. Continuous means that a function is smooth and unbroken. In other words, you could draw the graph of the function without ever lifting your pencil from the page. The second thing is that polynomial graphs often have what are called extrema, or what you might think of more colloquially as turning points. Turning points are points where the function changes direction from decreasing to increasing or vice versa. For example, let's look at this parabola we have over here. As we see, as we move along the path of the function from left to right, initially the function is decreasing, and then all of a sudden we reach the bottom of this valley and the function begins to go up, it begins to increase. We would call this type of turning point a minimum. It is the lowest point on the path of the function, at least from what we can see here. We also have another type of extrema that we call a maximum. It's exactly what you'd expect. It's where we go from increasing to decreasing. A maximum is the highest point that we see at a particular area in the function. When we talk about extrema or turning points, there are two distinctions we have to pay attention to. The first is the distinction between maximum and minimum. What's a high point and what's a low point? But the second, even within that, we still have to distinguish between what is called an absolute extrema or a relative extrema. For something to be relative means that it kind of depends on the circumstances. What's going on around it, what's near it in the picture. Maybe if we zoom out a little bit, things might change. With a negative leading coefficient. In this case, we know that like any quadratic, this will have a vertex somewhere up here. And this vertex is what we would call an absolute maximum in this case. We see that there's no point on the function that goes higher than the vertex. An example of an absolute minimum, on the other hand, would be the vertex of an upward-facing parabola. So we can draw the same picture, but we flip that leading coefficient to a positive, make this an upward-facing parabola, right? Same thing, this now has a vertex, only now the vertex is at the bottom of the function, right? But we see this is an absolute minimum because no point on the function goes lower than our vertex. A relative minimum, a relative maximum on the other hand will come in some kind of polynomial that maybe looks like this. So think for a second, what must the degree of this polynomial be? Even or odd? The answer is odd. If we see the left end is moving in a completely different direction from the right end, that should be a cue that this is some odd degree polynomial. Maybe this is some kind of cubic polynomial with a few more twists and turns. In any case, we see that there are actually 2 points on the function where this changes direction. 2 turning points on the function. For right now, let's focus on the relative maximum. So where do we have a relative high point? A point that is higher than what's around it, but is not necessarily the highest point on the function. If you look closely, you'll see that that is going to come right here. Right? We've got a little hill up at this point. But if we compare that point to the rest of the function, we see that it's not nearly the highest point on the function, right? Everything from here above is higher than this turning point. Nevertheless, we have to account for the fact that there's a change of direction here. So we would call this a relative maximum. On the other hand, if I kind of replicate this picture down below, we see we've got the same situation, but kind of its opposite. So if I look at the point that is lower than what's around it, but is not the lowest on the function, I see that I have one right here, right? I see that I've got a little valley, there's a change of direction, my function goes from decreasing to increasing, but this red dot is by no means the lowest point on the function. Everything on the left end goes lower than that point. So we would call this a relative minimum.